As a data scientist, most of your time will be spent in data preprocessing, where you might spend 60 to 80%, performing data cleaning, data transformation, data redaction, um, all those different components, right? With the objective to improve the performance of your model. One of these techniques is called feature scaling. In data preprocessing, we call this data normalization, right? Where you're trying to bring all these independent variables or features that might have varying degrees, magnitude, or range of units, right, into one range. Okay, so this process is called data normalization. Now, it's important to note that, again, this step can significantly improve the performance of your model. Sometimes it might not, right? Sometimes there might even be a decrease. So as a data scientist, you might need to try different tricks and tips on how to improve the performance. Could be, tuning your classifier, different parameters, or performing other additional steps, Z-score normalization. If you have an outlier, we have robust scale and so on and so forth. But let's look at how to implement this in Python. So to do Z-score normalization, we access this module from sklearn library called preprocessing, from data preprocessing. We've already looked at this. Then we import standard scale. When we go to the official reference, standard scaler here just means removing the mean and scaling to unit variance. And it's given by this equation here, right? So you're removing the mean divided by the unit variance. Remember, standard deviation is just the square root of that. So now that we have that, again, we just import pandas to load our data set. Then we split the data into X and Y. Then again, we split the data into training and test set based on X and Y. Again, we maintain here 80-20% split. Then we build our standard scaler here. We instantiate a copy of this, right, and call it SC, right? Now, the next thing we want to do is to pass this training set, 80% of our training set, right? We transform and then we fit. Okay, we fit and transform. All this be one step, right? And then we call this X-train normalized. And then we again pass the standard scaler. This time around, we just transform the test set, right? And then we call it X-test, Z normalized, right? You can see the shape here of both the training set and the normalized training set and the normalized test set. All right. Okay, so I've already run this. So again, with the perceptron, the only thing that changes here, we only fit instead of the normalized data set, we just fit the Z-score normalized data set. That's the only difference here. Everything remains the same. And for test here, we just pass the X-test. So we'll do this for all the different classifiers. So we just pass the normalized training set and we pass the normalized test set, when we want to evaluate the model, right? So again, these are the performance for recall from the previous and normalized models. So you can see here, perceptron was 70%. Here, there's actually a decrease, right? 64%. Moving forward, we see decision tree here, 56%. With the normalized here is 62%. So clearly there seem to be a trend here. Naive Bayes here, we can see 56%. Here was actually higher. When we look at KNN, 47%, KNN here 50%. SVM 56%, SVM here 53%. So actually using SVM is where we've seen some improvement. So you can see there's some classifiers which might not actually show some improvement, right, when you perform some of this. So, but in the real world, you come across some data set that have varying, varying ranges of different features. So at this point, then it would be nice to apply this type of data preprocessing steps. So in conclusion here, we can say that, with the feature scaling, not always does it improve your model performance, right? Like there's some models that might not require you to use feature scaling, right? But when used correctly for real world data that can be very messy, then there's a high chance that you're going to improve the performance of your model. You can try, this preprocessing just gives quite a bit of other different, so if I click here, I can see there are other different preprocessing. We can use min-max scaler, one hot encoder when you have categorical variables. So robust scaler here, this is very robust to outliers when you have outliers. Min-max scaler. So you can see here we have quite a list of different data preprocessing functions that we can use to just try and bring our data so that they can be of high quality. Okay, so with that, that's feature scaling using Z-score normalization.